So we proceed to Orifice. Ito yung analysis of flow of liquid from small holes or yung maliliit na butas. So for example, how do we compute for the velocity of flow from an orifice? So basically, yun yung potential energy ng liquid na magiging kinetic energy. So ano ba yung potential energy? This is the mass times acceleration due to gravity times the head. Yun yung height ng liquid above the orifice, considering that the liquid surface is zero pressure. Is equal to the kinetic energy. Ito yung 1/2 mass times the velocity squared. So if we are to cancel mass, and for example, we are solving for the velocity. So velocity is equal to, we have the velocity is now equal to the square root of 2g h. Pero ito yung theoretical velocity, the b sub t. Bakit naging theoretical velocity? Dahil ay paglabas ng liquid dito sa orifice, kapag maliit yung butas, nako-contract yung liquid. Ang tawag natin doon sa contracted cross-sectional area na yun is this is the vena contracta. Dahil hindi na ma-maximize yung actual area ng orifice, naging theoretical velocity yan. Kung i-apply natin, for example, yung formula ng discharge, the discharge equal to area times the theoretical velocity. This is also the same as the theoretical discharge. And sabihin na lang natin, A sub O ay the area of the orifice. Kaya kung nagko-compute tayo, for example, ng theoretical discharge, ito yung area ng orifice, the square root of 2g h. So kung theoretical values yung mga to, ay theoretical, which means hindi sila yung actual values, paano natin i-compute yung mga actual discharge? So para makakompute tayo ng mga actual discharge or actual velocity, gagamit tayo dito ng mga coefficients. Yung mga coefficients na to is basically nako-compute or nakukuha from laboratory experiment. So depende kung ano yung material. For example, plastic or metal or wood. So meron tayong coefficient of velocity. Ito yung C sub B. Ang C sub B is equal to the ratio of the actual velocity to the theoretical velocity. Kaya kung gusto natin kunin, for example, yung actual velocity, ito yung coefficient of velocity times the theoretical velocity. Or velocity actual is equal to C sub B ay the square root of 2g h. So maglalagay lang tayo or magmumultiply lang tayo ng coefficient para makuha yung actual values. So the same with the discharge. Sa ibang reference, C. Sa iba naman is C sub D. Ito yung ratio ng actual discharge sa theoretical discharge. Okay, so for example, gusto natin kunin yung actual discharge. So the actual discharge is equal to C sub D times the theoretical discharge. Or actual discharge is equal to, we have the C sub D. Okay, ano ba yung equivalent ng theoretical discharge? Okay, this is the square root or area ng orifice. Okay, the area of the orifice, the square root of 2g h. Okay, if you're computing for the actual discharge. So, meron din pa tayong isa pang coefficient. Ito naman yung coefficient of contraction. Ay sabihin natin na ito yung C sub C. Coefficient of contraction is the area actual. Ito yung area ng vena contracta. Yun yung contracted cross-sectional area ng liquid paglabas niya sa orifice. So, area actual is the area of the vena contracta divided by yung area ng orifice. Kino-consider natin na theoretical yung mismong dimension ng maliit na butas. For a reason, yun nga, hindi naman na ma-maximize yung kanyang cross-sectional area. So we have the coefficient of contraction is the area actual over the area of the orifice. Okay? Kung babalikan natin yung basic natin na discharge is equal to area times velocity, okay, ito naman yung relation ng mga coefficients. Ano ba yung coefficient natin pagdating sa discharge? Ito yung coefficient of discharge. Pagdating sa area, ang coefficient naman natin is the coefficient of contraction. Pagdating sa velocity, ano yung coefficient? Ito yung coefficient of velocity. So basically, okay, the coefficient of discharge is equal to the coefficient of contraction multiplied by the coefficient of velocity. So ito yung basic muna natin pagdating sa orifice. Okay, so let's have an example. Alright, so let's have our first example for orifice. So a circular orifice is located 5 meters below the water surface. If the tank is large and the diameter of the orifice is 5 millimeters, calculate the discharge if the coefficient of discharge is 0.6. So, ito yung case ng board exam problem kung tawagin is yung constant head. Okay, constant head problem dahil kahit nababawasan ng liquid, hindi natin i-assume na bumababa yung height ng tubig or the head of water. So, how do you compute for the discharge? Kapag nagbibigay ng coefficient, basically, actual discharge yun. So, actual discharge is equal to coefficient of discharge times the theoretical discharge. Okay, actual discharge is equal to the coefficient of discharge, that is multiplied by the area of the orifice, the square root of 2gh. More likely, parang direct sub lang ito. Walang nabanggit na pressure sa surface, kaya pressure equal to 0. We can use the head equal to 5 meters. So, direct sub. We have the flow rate actual is equal to, this is 0.6. Okay, area ng orifice, 5 mm. That is 0.0005 squared pi over 4. Ginawa ko lang meter. Yung 5 millimeters to meter is 0.005 meter. Multiplied by the square root of twice of 9.81. Multiplied by the head na given is 5 meters. Kung mag-unit analysis tayo dito, yung sagot should be in cubic meters per second. Pero yung nasa choices, nasa liters. Kaya mag-multiply tayo dito ng 1,000 liters is to 1 cubic meter. Okay, so we are computing now for the flow rate actual in terms of the liters per second. Okay, that is 0.6 multiplied by 0.005 squared. And this is sheep pi over 4, the area of the orifice. Then the theoretical velocity is twice of 9.81. Multiplied by the head 5 meters. And then multiplied by 1,000 to be in liters per second. That is 0.116685 or sabihin natin 0.117. Okay, kung 3 decimal places lang. 0.117 liter per second. So do we have this value sa choices? 0.117, that will be letter A, 0.117 liter per second. So this will be problem number 37. So let's have more example for orifice. So a liquid discharge from a container through a circular orifice having a diameter of 10 millimeters. That is located 5 meters from the liquid surface. Sa number 38, compute the theoretical discharge through the orifice. So ito yung mga given so far. Yung height ng tubig above the orifice is 5 meters. Tapos, dun sa number 38, wala naman siyang nabanggit din na pressure sa liquid surface. So we assume that to be 0. So, pwede natin gamitin na yung total head above the orifice is simply the same as the 5 meters. And nabanggit rin sa 38, theoretical discharge. So, theoretical discharge is yung area ng orifice, the theoretical velocity. So we have, this is the theoretical discharge is equal to the area of the orifice, the square root of 2g times h. So 10 mm or 0.01 meter. Okay, so more likely parang, direct sub lang si number 38. Computing for the theoretical discharge equal to area ng orifice, 0.01 squared pi divided by 4. Multiplied by the square root of 2 times 9.81. Then multiplied by yung given na head, that is 5 meters. So again, yung theoretical discharge na to will be in terms of the cubic meter per second. So multiplied by 1,000 liters is to 1 ay cubic meter. Para yung final answer, the final answer will be in terms of the liters per second. So compute natin. That is 0.01 squared shift by, this is divided by 4. Then multiplied by the square root of 2 times 9.81 multiplied by 5. That is cubic meters per second multiplied by 1,000 to be in liters per second. That is 0.778. Sabihin na lang natin. 0.778. Tama ba? 0.778. Yan. 0.778 ay liter per second. Check natin if we have this value sa choices. For question number 38. 0.778 is the same as, pinakamalapit na, letter A tayo. 0.78 liter per second. Sa number 39, if the container is accelerating upward to half of gravity, compute the theoretical discharge. So, kanina, steady lang, pero for problem 39, mag-a-assume tayo na yung container na to, nag-a-accelerate daw upward to half of gravity. So, that acceleration is the acceleration due to gravity divided by 2. Okay? So, based yun na sa problem 39. Ang sabi niya, half of gravity. So, paano natin kukunin yung theoretical discharge? So, sa number 39, hindi natin pwedeng gamitin yung head na equal sa 5 meters. Okay? So, take note na yung pag-accelerate ng tangke, yung paggalaw niya pataas, may effect yun. Okay? Parang mas lalakas yung pressure na magtutulak para lumabas yung liquid. So, basically, ano ba yung reason? Bakit lumalabas yung liquid dito sa butas sa ilalim? Basically, because of the pressure. Okay, paano natin kunin yung pressure sa ilalim kapag nag-a-accelerate siya upward? Okay, recall lang natin ng konti yung lecture natin sa fluid mechanics, the relative equilibrium. Ito yung pressure is equal to gamma H multiplied by 1 kapag pataas plus the acceleration divided by the acceleration due to gravity. Okay, kapag upward. Okay, kunin natin yung total pressure na nagkokos para lumabas yung liquid. Okay, so we have the pressure dito sa ilalim ng tangke is gamma, do hindi niya sinabi kung anong tubig, kung anong liquid ito, pero i-assume natin na tubig. That is 9.81, yung height ng tubig is 5 meters, pero hindi siya yung total head. Okay, hindi natin pwedeng sabihin na yung total head is 5 meters. Then, multiplied by, we have 1 plus, yung acceleration is half of gravity daw. So, that is the acceleration due to gravity divided by 2 divided by the acceleration due to gravity. So, pwede nating i-cancel yung G dito. So, we'll be having the total pressure dun sa ilalim ng tank will be equal to, that is 9.81, multiplied by the height of the water, 5, multiplied by 1 plus, that's the same as 1 half na lang, since na-cancel na yung G. So that is equal to 73.575. 73.575 kilopascals. Okay, ito yung total pressure na nagkukos dun sa liquid para lumabas. Ngayon, paano natin kukunin yung kanyang equivalent head? So, dahil yun sa paggalaw niya pataas, kunin natin yung equivalent head. Okay, equivalent head or yung total head. So, gamitin ko na lang this time, capital H. So, basically, ano ba yung basic equation natin sa pressure? I-reinterpret lang natin. Yung pressure is basically equal to gamma H. Ayun lang naman siya. So, the total pressure that causes the liquid to flow, okay, from the orifice is 73.575. Equal to gamma 9.81 times, ano yung equivalent na total? Ay, total head. So, that is, ay yung total head natin dito, I will be equal to 73.575 divided by 9.81. So, divided by 9.81. So, ang total head natin this time is 7.5 meters. So, mas mataas na siya for a reason. Ayun yung effect ng acceleration na upward. So, inahanap pa rin natin dito yung theoretical discharge. So, we have the theoretical discharge is equal to this is the area of the orifice, the theoretical velocity, or equal to the area of the orifice, the square root of 2g h. So, ito yung total head yung gagamitin natin this time. Okay, so we have the theoretical discharge. Area ng orifice kanina is 0.01 squared pi divided by 4. Then, the square root of 2 times 9.81, total head dahil sa acceleration na upward is 7.5 meters. Okay, kunin natin yung theoretical discharge. Again, this is in terms of the cubic meter per second multiplied by 1,000. Para yung theoretical discharge natin will be in terms of the liters per second. Okay, so this is 0.01 squared shift pi divided by 4 multiplied by this is the square root of 2 times 9.81 multiplied by 7.5. So yung result na to ay cubic meters per second multiplied by 1,000. That is 0.953. 0.953 liter per second. So, check natin sa question number 39. If we have this value, 0.953, pinakamalapit na dito sa letter C, 0.95. Sa question number 40, meron na tayong mga coefficients this time. If C sub C equal to 0.65, and C sub B is 0. Baliktad. If C sub C is 0.65 and C sub B is 0.95, compute the actual discharge. Okay, kaya lang hindi niya binanggit dito sa question number 40. Hindi niya binanggit kung anong situation. Yun ba yung situation na hindi siya gumagalaw or yung situation na nag-a-accelerate siya upward? Pero, okay, i-assume natin na stationary siya, hindi siya gumagalaw. Kung stationary at walang acceleration na nangyayari, ay gagamitin natin yung original na head. Yun yung 5 meters. So, given yung C sub C equal to 0.65, yung C sub B equal to 0.95. Okay, check ulit natin yun. 0.65, 0.95. So, kapag given yung mga coefficients, naghahanap na tayo ngayon ng actual. Okay, the C sub D is equal to C sub C multiplied by C sub B. Okay, kunin natin yung coefficient of discharge. So, 0.65 of 0.95. That is 0.615, 0.6175. 0.6175. Okay? So, kapag naghanap na tayo ng actual discharge is C sub D, area of the orifice, theoretical velocity. Or C sub D, area ng orifice, ay the square root of 2G times H. So, i-assume natin na hindi siya gumagalaw, ay the flow rate actual is equal to 0.6175. Area ng orifice is 0.01 squared pi. This is divided by 4. Then, multiplied by the square root of 2 times 9.81 ay yung given na initial head, the 5 meters. So, flow rate actual will be in terms of the cubic meter per second ay multiplied by 1,000. Okay, since lahat naman yata yung nasa choices sa problem na to, situational problem, ay nasa liters per second. Kunin natin. Is 0.6175 ay multiplied by the area of the orifice, 0.01 squared. Okay, shift pi over 4. And then multiplied by the square root of 2 times the 9.81 ay multiplied by 5 meters. And then multiplied by 1,000 to be in a liter per second. 0.48 liter per second. So, tingnan natin if we have this value sa question number 40. So, 0.48, letter D tayo. Pero tingnan natin, paano kung yung nag-a-accelerate siya pataas? Kung nag-a-accelerate siya pataas, ay ang gagamitin naman natin doon is yung total head kanina. Yung head is equal to 7.5 meters. Kung nag-a-accelerate siya upward at yun yung G over 2. So, pwede natin i-edit yung value na yun kanina. Ay, edit lang natin ito. Palitan lang natin yung 5 ng 7.5. Then, tingnan natin kung nasa choices. That is 5.88. So, times 1,000. Okay, that is 0.588. Yung flow rate actual naman nito is 0.588 ay liter per second. So, tingnan natin kung ito yung case na hinahanap. Or yung sinasabi niya sa number 40. So, wala tayong 0.58. So, more likely, ay yung sagot natin na nauna, yun yung correct answer. Stationary lang siya, hindi siya gumagalaw. And the head is 5 meters. So, ito yung solusyon natin for problem 38, 39, and 40. Okay, tuloy tayo sa number 41. A large closed cylindrical steel tank 4 meters high with its bottom on a level ground ay contains 2 layers of liquid. So, the bottom layer is water. So, the specific gravity is equal to 1. 2 meters deep. The top layer is occupied by a liquid whose specific gravity is not known. Okay, to a depth of 1 meter. The airspace at the top is pressurized to 16 kilopascals. A 50 mm diameter orifice with C sub B equal to 0.98 is situated 1 meter from the bottom of the tank. So, the jet from the orifice hits the ground 3.5 meters horizontally away from the vena contracta. Determine the specific gravity of the liquid. So, ito yung illustration natin para sa problem na to. So, hangin, 16 kilopascals, 1 meter na unknown liquid, tapos 2 meters na tubig. Yung orifice is 1 meter from the bottom of the tank. Okay, balikan natin yung concept. Ay, bakit ba lumalabas yung liquid dito sa orifice? That is basically because of the pressure. So, sabihin na lang natin, P sub O, the pressure on the orifice. So, paano ba tayo nagko-compute ng pressure? So, yung pressure hanggang doon sa orifice is the summation of all pressures. So, kunin natin yung pressure dito or balikan natin ano ba yung basic concept ng pressure. That's the same, pwede natin sabihin, summation of gamma ay gamma H. Yung pressure dito sa orifice is equal to, so kunin lang natin yung summation. Initially, meron tayong air pressure na 16 kilopascals. So that is 16 plus ay gamma H. Okay, unknown liquid lang naman kasi siya. Kaya ilalagay muna natin specific gravity S times gamma water 9.81 times yung height niya ay 1 meter. Ito yung pressure para dun sa unknown liquid na gamma H. Okay, so since 2 meters yung depth ng tubig, ay 1 meter din yung hanggang dito sa orifice. Okay? So, 1 meter din ng tubig. So, that is gamma H. So, plus, okay, tubig yon. Okay, 9.81 times yung height hanggang sa orifice is 1 meter. O, tignan ta, ang kinukuha natin is yung pressure hanggang sa orifice lang. So, the pressure hanggang dun sa orifice is equal to, that is, yun yung 16 plus 9.81. That is equal to 25.81. So, sabihin natin, this is 25.81 plus yung portion na to, that is 9.81 times the unknown specific gravity. Ito yung pressure hanggang sa orifice, yung nagkakos kung bakit lumalabas yung liquid. So, para saan naman yung mga given na to? Okay, yung y is equal to 1, saka yung x equal to 3.5. So, ito yung mga actual values, okay, actual displacement ng tubig, and yung mga values na yan, sila yung magbibigay ng actual velocity. So, gamitin lang natin yung formula natin sa P6, yung sa projectile. Yung babagsak yung projectile from a higher position to a lower one. Okay, recall lang natin yon, yung formula na yan, we have the y is equal to x, the tangent of theta minus the gx squared. This is divided by twice. Okay? Kung ito yung mga actual displacement ng tubig, okay, ang makukuha natin is actual velocity. So, twice the actual velocity squared, okay, the cosine of theta squared. Okay? So, ano yung value ng theta na gagamitin natin dito? So, yung initial direction ng tubig is horizontal kapag vertical yung wall na pinanggalingan niya. So, which means yung theta natin dito will be simply equal to 0 degrees. And yung tangent 0 is the same as 0. Then, i-recall natin, ano yung rule natin sa P6 kung babagsak sa mas mababa yung projectile. Kung mas mababa, yung value ng y should be negative. Okay? Negative yung value ng y kung babagsak siya sa mas bababa. Okay, mag-substitute na tayo para makuha yung value ng actual velocity. This is negative 1, yun yung value ng y, is equal to 0 minus 9.81 horizontal displacement, 3.5 squared. This is divided by twice the actual velocity squared. Ano pala ang equivalent ng cosine 0? Ang cosine 0 ay 1. So, parang 1 na lang yung nandito. Okay, so obviously, pareho silang negative. Yan, magka-cancel na lang yung sign na negative. Kunin natin yung actual velocity. So that is the same as 9.81 times x 3.5 squared. This is divided by 2. Okay, then square root. That is 7.752. So, 7.752 meters per second. Ayan. So, saan natin gagamitin yan? And bakit siya nagbigay ng coefficient of velocity? Okay, paano ba tayo nagko-compute ng actual velocity? Actual velocity is the coefficient of velocity times the theoretical velocity. I-recall natin yun sa intro kanina. Ito yung, okay, the actual velocity is c sub b, the square root of 2g h. So, ang purpose lang nito is para makuha natin yung total energy head or total head na nagkukos ng actual velocity na to. So, we'll be having, okay, the actual velocity is 7.752 equal to 7.752 c sub b ay 0.98, that is the square root of 2 times 9.81 ay multiplied by yung h. Ay, kunin natin yung total energy head that causes this actual velocity. Ay, yung stored value na lang gamitin ko, this is divided by 0.98 ay tapos squared. Tapos divided by 2, tapos divided by 9.81. Yan, tama kaya ito? That is 3.189. Sabihin na lang natin 3.189 meters. This is the total energy head that causes this actual velocity na nagbibigay ng ganitong displacement. Kung i-recall nyo sa hydraulics lab, ginagawa nyo ito. Okay, so after natin makuha yung H, ano nang susunod dyan? Balikan natin yung pressure equation natin hanggang dito sa orifice kanina. Okay, ito yung the pressure up to the orifice is equal to 25.81 plus the 9.81 times the specific gravity. Basically, paano ba tayo nagko-compute ng pressure? Pressure is gamma H. Yun. So, i-reinterpret lang natin. I-reinterpret lang natin, ano yung gamma? So, take note na yung gamma na to, yun yung gagamitin natin sa tubig dahil yun yung nasa orifice. So, that is, gamma is 9.81. Ano yung total head na nakuha natin? The total head that causes this displacements. Ang total head is 3.189. Yung nag-cause ng ganitong actual velocity. 3.189 meters. So, multiplied by 3.189 meters. So, basically, gamma H. Yun yung equivalent ng pressure. Pero dito sa pressure sa orifice, anong equivalent? Yun yung 25.81 plus the 9.81 times the specific gravity of the unknown liquid. So, kunin natin. That is 9.81 multiplied by 3.189 is equal to 25.81 plus the 9.81 of the specific gravity. Shift solve. That is 0.558. So the specific gravity of the unknown liquid is 0.558. So check natin if we have this value sa choices for question number 41. Okay, so yung nandito is 0.56. Okay, pinakamalapit sa 0.558. And one thing more, okay, dito, di ba habang papailalim, nag-i-increase supposedly yung specific gravity. So dapat, kung tubig yung nasa ilalim, yung expected specific gravity natin is less than 1. Kaya kung manghuhula tayo, hindi pwede si letter C, hindi pwedeng isagot si letter C at saka si letter B dahil sila ay greater than 1. So possible ang option lang natin sana kanina, 0.56 at saka 0.95. Okay? So this will be our solution for problem 41. Okay, dito naman tayo sa number 42. A tank which is 1 meter square in cross-section is filled with 3 meters of oil with a specific gravity equal to 0.8. If a standard 80 mm diameter orifice is opened at the bottom with C, or that is the coefficient of discharge, 0.6, how long will it take to lower the liquid surface by 2 meters? Kapag may involved na time, okay, ito na yung case ng orifice na the falling head. So, magko-consider na tayo dito ng pagbaba ng liquid surface, the falling head. So, yung pinaka-basic concept nito para sa formula is that yung basically ang discharge is the differential volume divided by the differential time. So, negative differential volume over differential time. Negative siya dahil nababawas. Kaya kung gusto natin kunin yung time equal to the negative differential volume, this is divided by the flow rate actual. Then, integrate natin from both sides. So, this is from 0 to t. Yung kabila naman, from initial head. The initial head. Okay, to the final head. So, yung derivation nito, ilalagay ko na lang yung link nung another video para dun sa derivation. Kasi medyo mahaba. Which is, ang result niya na formula, kapag in-integrate natin yan, ang resulting formula na to is the time is equal to negative twice the area. Ito yung area ng tangke. Okay, divided by C sub D, coefficient of discharge, area of the orifice, the square root of 2G, okay, multiplied by the square root of the final head minus the square root of the initial head. Okay, kapag yun, tinuloy-tuloy natin yung integration. So, balikan natin yung problem. Ito yung, okay, yung area ng tangke, sabi niya 1 meter square cross-section. So, the area of the tank is obviously 1 square meter. So, hinahanap natin yung time, gaano raw katagal para yung liquid surface, okay, lowered by 2 meters. Yun yung sinabi niya sa problem. So, lower the liquid by 2 meters. So, ang kailangan lang naman natin dito sa formula is yung initial head at saka yung final head. So, ano yung initial head natin? Kapag sinabing initial head, yun yung initial na height ng liquid above the orifice. So, that will be, our initial head number 1 is 3 meters. Kung bababa ng 2 meters yung liquid surface, ano na yung ating final head? So, yung final head, ito yung final na height ng liquid above the orifice. So, therefore, ang ating final head should be, okay, head number 2, 1 meter. Yan yung last na height ng liquid na given. Okay? Di ba tama? Okay, pag bumaba ng 2 meters, ang naiwan, 1 meter na lang. Okay, so mag-substitute na tayo. Okay, again, yung gagamitin natin na formula sa case na to, falling head, time is equal to negative twice the area divided by the coefficient of discharge. So, sa ibang reference, C, sa iba naman, C sub D, ay multiplied by the area of the orifice, the square root of 2G, and then multiplied by the square root of the final head minus the square root of the initial head. Okay, so we substitute. Okay, so this is the time equal to negative twice. Yung area ng tank is 1 square meter. Okay, divided by coefficient of discharge, given ito na 0.60. Ano naman yung area ng orifice? Okay, 80 millimeters or 0.08 meter squared pi divided by 4. Okay, then to be multiplied by the square root of 2 times 9.81. I-multiply natin ito sa the square root of, okay, ano yung ating final head, yung final na height ng liquid, that is 1 meter minus the square root, ano yung initial height ng liquid above the orifice, that is 3 meters. So, gamitin natin sila for a reason. Wala namang pressure. Okay, walang pressure na given sa liquid surface. So, take note, kailangan nyo rin i-observe yun just in case may given. So, we are computing now for the time equal to, this is negative 2 times the area of the tank, 1 meter, 1 square meter, okay, C sub D, 0.6. Okay, area ng orifice is 0.08 squared, okay, shift pi, okay, divided by 4. And this is the square root of 2 times 9.81. Then multiplied by the square root of the final head is 1. Initial head is minus the square root of 3. So, take note, pag sinabing head, yun yung height ng liquid above the orifice. So, yung nakuha natin dito is 109.597. Ay 109.597 seconds. Seconds, ito kasi yung ginamit natin dito is 9.81 meters per second squared. So, 109.597 seconds. So, check natin ito sa choices for question number 42. 109.597. So, pinakamalapit na dito will be letter D, 109.6. So, this will be our first example, falling head. Question number 42. So, we proceed sa problem number 43. An open cylindrical tank 4 meters in diameter and 10 meters high contains 4 meters of oil, specific gravity 0.8, and 6 meters of water. An orifice 100 millimeters in diameter is located at the bottom of the tank with C sub C equal to 0.90, C sub B 0.98. So, find the time to discharge all the contents. So, dito, ay kunin muna natin yung gagamitin natin na C sub D, the coefficient of discharge equal to C sub C times C sub B. So, that is 0.90 of 0.98. So, we have the coefficient of discharge now equal to so we have 0.9 times 0.98. That is equal to 0.0882. Okay, so hinahanap natin dito yung total time to discharge all the contents. So, kaya lang, kung i-recall natin yung ginamit natin na formula from the previous example, that is yung time equal to negative twice the area of the tank divided by coefficient of discharge, ayan ang orifice, the square root of 2g, okay, multiplied by the square root of the final head minus the square root of the initial head. Take note na yung formula na to. This formula is applicable only for one liquid only. So, applicable lang siya kapag isa lang yung liquid or uniform dapat yung liquid natin. Kaya lang dito kasi is composed tayo ng tubig at saka oil. So, ang una nating gagawin, hindi natin makukuha yung total time agad-agad. So, kailangan separate. Let's say this is time number 1. Ito yung time para maubos. Yung unang mauubos is yung tubig since yun yung nasa ilalim. So, let's say time number 1 to discharge all the water only. Kaya, dapat gawin natin na isang liquid lang ito. So, paano natin i-convert yung oil? Paano natin i-convert yung oil? Gagawin natin siyang tubig. So, parang in terms of pressure. So, sabihin natin na parang yung pressure ng oil is equal to the pressure ng water. So, yung pressure ng oil is gamma H. Ano yung kanyang gamma? 0.8 times 9.81 times, ano yung height ng oil? That is 4 meters. Is equal to gamma water, 9.81. Okay, let's say H sub 2O. Ano yung equivalent height ng oil in terms of water? So, ito yung height in terms of water ng oil. So, pwede na nating i-cancel dito yung 9.81. Ano yung 0.8 of 4? So, 4 times 8 is 32. So, sabihin natin, 0.8 times 4 is 3.2 meters. So, 3.2 na height ng tubig, pero in actual, again, this is oil. Kumbaga, parang i-convert lang natin yung oil para maging tubig, para maging uniform yung liquid natin. So, ngayon, ay converted na siya as, lahat nito ay tubig na. Okay? So, initially, ang nadagdag lang dito, pero take note parang imaginary water pa rin yan. Imaginary water pa rin yan dahil in actual, oil pa rin yan. Yung initial height ng tubig is 6 meters, so may nadagdag na 3.2 meters. Yun yung equivalent ng oil. So, ito yung magiging total initial head natin. Let's say this is H number 1. This is H number 1 equal to, ano yung 6 plus 3.2? That is 9.2 meters. Okay, ayun. So, meron na tayong head number 1 para dun sa tubig. So, head number 1 is equal to 9.2 meters. So, ang tanong dito, ano yung magiging final head kapag ubos na yung tubig? Okay? Ano yung magiging final head kapag ubos na yung tubig? Yun ay kung matatanggal na yung 6 meters na actual water. Take note yung actual na tubig natin dito ay 6 meters. Pagkaubos niyan, ano na yung naiwan? So, ang naiwan in actual is yung oil na 4 meters. Pero ano yung equivalent niya in terms of water? Yun yung ilalagay natin. So, ang equivalent niya in terms of water, ito yung maiiwan na height, which is the 3.2 meters. Dahil in actual, ang tatanggalin lang talaga natin ay 6 meters na tubig. Kaya 9.2 minus 6 is 3.2 meters. So, ang final head natin should be 3.2 meters. Okay? Dahil tinanggal natin yung actual height na 6 meters ng tubig. Okay, so mag-substitute na tayo. This is time number 1. Okay, time number 1, time to discharge the water only. Okay, ano yung diameter ng tangke? 4 meters. So this is, negative 2. Diameter of the tank is 4 squared pi divided by 4. So all over, C sub D is 0.882. Ano yung area ng orifice? So, area ng orifice is 100 millimeters in diameter or in meter, that is 0.1 squared pi divided by 4. Then this is multiplied by the square root of 2 times 9.81. This is to be multiplied by the square root of initial head, final head pala. Final head is 3.2. The final head is 3.2 minus the initial head, that is 9.2 meters. So this is time number 1, time to discharge all the water. Compute natin. This is, we have negative 2. The area of the tank is 4 meters in diameter. 4 squared pi over 4. This is divided by coefficient of discharge, 0.882. Area ng orifice is 0.1 squared by ship pi divided by 4. Then multiplied by the square root of 2 times 9.81. To be multiplied by the square root of the final head, 3.2. Initial head na tubig lahat is 9.2 or the square root of 9.2. This is in terms of seconds, so 1019.191 ay 1019.191 seconds. Okay, that is, ulitin ko. Ito yung total time to discharge all the water only. Okay? So again, applicable lang kasi yung formula na to kapag one liquid lang. So, kailangan nating ang ginawa natin, kinonvert natin yung oil in terms of water. Pero ano yung actual height ng tubig? 6 meters. So 9.2 minus 6, the final head should be 3.2. Okay, ngayon, pagkatanggal ng tubig, in actual, ano na yung naiwan? So, actual ito. For the actual, ang naiwan na doon, pagkatanggal ng tubig, ay naiwan na oil with a height of 4 meters. So, ano naman yung magiging initial head natin at saka final head? Dito, ang initial head will be 4 meters. Kapag paubos na or ubos na, the final head should be equal to 0. Yun yung ating initial head and final head. Siguro ang tanong, bakit 4 meters? Bakit hindi 3.2? Dahil mag-isang liquid na lang naman ito. Mag-isang liquid na lang siya. So, applicable na yung formula natin na time equal to negative twice area divided by the C sub D, area of the orifice, the square root of 2G. This is multiplied by the square root of the final head minus the square root of the initial head. So, bakit yun, kanina, kailangan i-convert as water, basically, para maging uniform liquid. So, ang ibig sabihin din ng additional head, bakit yung total head ng tubig ay 9.2, ang ibig sabihin lang nun is tinutulak ng oil. Okay? Itinutulak ng oil yung tubig, okay, para lumabas siya. Additional pressure yun, yung bigat ng oil, nakakatulong para lumabas yung tubig. So, let's say, ito yung time number 2, ito yung time to discharge oil only. So we have the total time number 2, that is equal to negative twice. Area ng tangke is 4 squared pi divided by 4. This is divided by C sub D, kanina, 0.882. Area ng orifice, 0.1 squared pi, ay divided by 4. Then, multiplied by the square root of 2 times 9.81. Then, multiply na lang natin dito. The square root of the final head, that is 0, minus the square root of the initial head, that is 4. Okay, time number 2, time to discharge all the oil only. So, i-edit lang natin yung input kanina. Yun lang. So, palitan ko lang ito ng 4 at saka 0. Well, it's 1,638.181. So, 1,638.181 seconds. Okay, kaya lang yung nasa choices ay nasa minutes. Okay, i-compute na natin yung total time. Okay, the total time is basically time number 1. Time number 1 plus time number 2. Ganito kapag layers of liquid, kailangan separate. Okay, the total time is now equal to 1,019.191 plus 1,638.181. Nasa seconds yan kapag i-convert natin sa minutes divided by 60. We'll be having the total time. That is 1019.191 plus 1638.181. In seconds divided by 60 to be in minutes. That is 44.2, sabihin na lang natin, 44.23 minutes. Okay, check natin if we have this value, 44.23 minutes sa choices. 23, bakit 23 yun? 44.29, not 23. Okay, so this should be 44.29 minutes. Tama ba? 44.2895. Okay, 44.29 minutes. Okay, check natin sa choices. That will be letter. Letter D tayo, 44.29 minutes. So this will be our solution for problem 43 kapag meron tayong layers of a liquid. Okay, so we proceed to problem 44 to 46. Two vertical cylindrical tank, one is 5 meters in diameter and the other is 8 meters in diameter, are connected by a short tube having a cross-sectional area of 0.004 square meter. Yung C, or the coefficient of discharge, is 0.6, located at the bottom portion. When the tube is closed, the water surface in the smaller tank is 10 meters higher than that in the bigger tank. So number 44, I determine the discharge in the tube immediately after it is opened. Okay, so parang ito yung setup natin. So ito yung smaller tank natin, 5 meters in diameter. Yung larger tank, 8 meters in diameter. Sabi niya sa problem, so 10 meters higher daw. So 10 meters higher yung liquid surface dito sa smaller tank compared dun sa larger tank. So sa number 44 is, hinahanap lang dito yung immediate discharge pagkabukas daw nung orifice natin, yung short tube. Kung wala namang binigay na length, ine-neglect natin yung mga head loss dun sa tube. So basically, ang hinahanap lang natin sa number 44 is the actual discharge. Initial actual discharge. Ito yung coefficient of discharge, area of the orifice, the theoretical velocity. Using yung initial head na meron tayo, yun yung difference in the level of water, that will be equal to 10 meters. Okay, so mag-substitute lang sa number 44. We have the flow rate actual is now equal to, that is 0.6, given na yung area, 0.004 square meter. Then, multiplied by the square root of 2 times 9.81. Okay, pagkabukas daw, immediate head is 10 meters. So, be having the flow rate actual. So, based sa units, ang lalabas na unit nito ay cubic meter per second. So, mag-multiply tayo dito ng 1,000 liters is to 1 cubic meter. Para yung sagot natin will be in terms of the liters per second. So question number 44. That is 0.6. Area ng orifice is 0.004. Then the square root of 2 times 9.81. Immediate or initial head is 10 meters. Then ito ay cubic meter per second multiplied by 1,000 to be in liters per second. That is 33.617. 33.617 liters per second. So tingnan natin kung meron tayong ganitong value sa choices for question number 44. So 33.617, that will be closest to letter A, the 33.6. Dito sa number 45, I determine the time elapsed for the water surface in each tank to be at the same level. So, kapag 2 tanks na yung usapan, dalawa yung tanke, ito yung tinatawag nila minsan na submerged condition. Submerged condition, that is kung magko-consider tayo ng 2 tanks or dalawang containers. So, kung dalawang containers, hindi na applicable yung nauna nating formula kanina. So, kapag 2 containers na tayo, parang ganun pa rin yung concept. The flow rate actual is equal to negative differential volume divided by the differential time. Kung i-derive natin yon, so again, ipopost ko na lang yung link ng derivation para dito. Ito yung time is equal to negative twice of area 1 times area 2. This is divided by area 1 plus area 2, multiplied by the coefficient of discharge, the area of the orifice, the square root of 2g. This is to be multiplied by the square root of the final head, h sub 2, minus the square root of the initial head, h sub 1. Yan yung gagamitin natin na formula kapag submerged condition, which means parang paglabas ng tubig under water siya or under the liquid surface. Kapag dalawang tangke, ito yung equation na gagamitin natin. So obviously, ito yung magbibigay ng area 1. Ito naman yung magbibigay ng area 2. So the first tank and the second tank. So sabi niya sa number 45, the time elapsed for the water surface in each tank to be in the same level. So ano yung magiging initial head natin? So number 45, ang initial head is yun yung given na 10 meters. Yun yung initial na height ng tubig or the difference in a water surface. Kapag the same level, for example, eto na yun. Yan. So again, yung ating initial head is equal to 10 meters. Kapag the same level na sila, ano yung remaining head? Okay? Kapag the same level, ano na yung remaining head? That is 0. Ibig sabihin, kapag 0 head, titigil na yung flow dahil balance na yung water surface. Okay? So, the final head should be equal to, dito sa number 45, kapag same level, the final head is equal to 0. Kasi pag sinabi nating head, yun yung difference in elevation between the liquid surfaces. So, mag-substitute tayo. So, this will be the time equal to negative 2. Ano yung area ng tank number 1? Yun yung 5 squared pi divided by 4. Area ng tank number 2, yun yung 8 squared pi divided by 4. Okay, so all over, area 1, that is 5 squared pi divided by 4 plus area 2. This is 8 squared pi divided by 4. Coefficient of discharge, given yun kanina na 0.6. So, check natin kung 0.6. That is 0.6. Area ng orifice, binigay din yun as 0.004 multiplied by the square root of 2 times 9.81. Then, multiplied by the square root of final head kapag same level, that is 0. Initial head natin, yun yung initial difference in our liquid surface, 10 meters. So, kunin natin. Okay, so this is negative 2. That is 5 squared pi over 4 multiplied by area 2, yung second tank. Okay, this is 8 squared pi divided by 4. Okay, to be divided by yung sum of the cross-sectional areas ng dalawang tangke. 5 squared pi over 4. Okay, plus, okay, that is the 8 squared pi divided by 4. Then, coefficient of discharge, 0.6. Area ng orifice, 0.00, 4. Then, the square root of 2 times, okay, 9.81. Okay, then, to be multiplied by, okay, the square root of final head, 0, minus, ay, the square root of the initial head, ay yun lang, wala nang space. So, ito na lang muna, yung constants. Equals, okay, times, okay, this is the square root of the final head, 0, ay minus the square root of the initial head, that is, ay 10. That's 8,400.19. So, the total time needed is 8,400.19 seconds. So, check natin if we have this value sa choices. Question number 45. So, yun na yun siguro. Letter C, 8,400. So, number 46 naman, determine the time elapsed for the difference in water surface to be 4 meters. Okay, for 46, okay, do we have problem number 46, ay ganun pa rin yung ating initial head, that is 10 meters. So sabi niya, ay hinahanap yung time para yung magiging difference in water surface to be 4 meters. Yun yung ating final head, the 4 meters. Kasi kung titingnan natin, di ba parang initially, 10 meters. Tapos, syempre, bababa itong source. Bababa siya. Yung receiver naman, tataas. So, from an initial head na 10 meters, yung magiging difference in level of the liquid surface will be 4 meters. Yun yung ating final head. Again, so take note na pag sinabi nating head, yun yung difference in elevation between the liquid surfaces. So, ang mangyayari dyan is, ang final head natin will be 4 meters. Okay, so edit lang natin yung mga nating values. So, again, the same property lang naman ito. Yung mga constants natin, diameters, coefficient of discharge, areas, equals, okay yan. I-multiply lang natin sa panibagong square root ng final head is 4. Then, minus, initial head natin, the square root of 10. Okay, that is equal to 3,087.44. So, the same lang dito. The same lang dito. Pinalitan ko lang. The same lang dito. Pinalitan lang natin ng 4 meters. Then, ganun pa rin yung initial head, 10 meters. So, we have the time is 3,087.44. We have the total time is 3,087.44 seconds. Okay, tingnan natin if we have this value sa choices. Question number 46. 3,087, that will be letter A tayo. So, ito yung solution natin for problem number 44 to 46. Lumabas na rin ito one time sa board exam.